Hello class. For this video, we're just going to be going through the PowerPoint as well as the how-to document. So if you go back to your modules here in your Canvas, it's going to be under week 7. And we're just going to go through here, this little PowerPoint right here. I'll publish it so you can view it. And then we're going to go over the how-to document and run the data for the music save. It's going to be a little bit of a long video. So let's start with the PowerPoint. So we're now getting into hypothesis testing and correlations. So this is really cool. This is the first time you're going to be looking at comparing variables together. So we practice writing hypotheses and understanding the variables and research designs involved in conducting scientific research. But now we're going to focus on how to test these hypotheses. So NHST stands for Null Hypothesis Statistical Testing. It's the standard way of testing your hypotheses in psychology. And the overarching question that stats help us answer is whether a statistical relationship between variables could have happened by random chance. So we're going to get into what that random chance actually means. But here's some examples of some null hypotheses. So whenever you have a research hypothesis, you're always going to have a null hypothesis. You're testing for that null hypothesis, whether you can retain or reject that null hypothesis. So for every hypothesis we just have, there is a null. It's notated as HO right there, H null, hypothesis null. And it's always that there is no statistical relationship between the variables. So for instance, here's an example right here. The Dr. X hypothesis is that the amount of time watching TV is associated with obesity. So the null hypothesis is that there's no statistical relationship there, not the opposite of that, but that there's no statistical relationship. So the amount of time watching TV is not associated with obesity. So the next example is very similar. So your research hypothesis is that disengaged parents are more likely to have anxious kids. So the null hypothesis is that disengaged parents are just as likely to have anxious kids as engaged parents. Or you could say there will be no relationship statistically between engagement in parents and the likelihood to have anxious kids or kids with anxiety disorders. Those are two null hypotheses. There's no statistical relationship. Now here's one that's a little bit tricky. So the hypothesis is that the number of friends someone has is not related to happiness. So the null hypothesis is the number of friends someone has is not related to happiness. Now you notice that it's the same as our research hypothesis because our research hypothesis in this instance was that there would be no statistical relationship. So the two hypotheses are the same. Remember, the null hypothesis is not the opposite of the research hypothesis. The null hypothesis is always that there is no statistical relationship. So if your research hypothesis is that there is no statistical relationship, your null hypothesis will be the same. Okay, let's move on to the next one. So the p-value. This is the most important value that you're going to confront in psychology. You're going to hear it all the time. You're going to use it all the time. So when you run a statistical test, there are a couple of ways to determine whether a hypothesis was correct or not. So in this lab class, we're going to focus primarily on this p-value. And the p-value tells us that the likelihood that an association between variables occurred due to random chance. So think of it this way. We have a p-value, and our threshold is 0.05. This is the most important number to remember here, this 0.05. You want to have a p-value of less than 0.05. Very, very important to remember that. So when you're creating a statistic, so if you're testing a hypothesis, you're going to get a p-value, and if that p-value is less than 0.05, that means that you have found a significant relationship between the variables, and that the relationship you found is probably not due to random chance. So if you ran this test 100 times, right, 95 times out of 100, you're going to receive a similar result and see that there is a relationship between these variables. This 0.05 is more of a percentage. So 5% of the time, you may receive an opposite value. This is the threshold that psychologists have decided on. So 95% of the time, you're going to see significance with these two variables if you compare them to each other. So that's important to remember. This is really the all-important p-value. So let's do some practice with the p-value. Cancel that here. So 0.05 is an important number as we discussed before. So let's do some practice. So, for example, my hypothesis is that people who were born in the South were more likely to prefer sweet food compared to people who were born in the North. My null hypothesis, that people are equally likely to prefer sweet food whether they're in the North or South. No statistical relationship. Now let's jump down to the last one. I conducted an ANOVA, you'll learn this term soon, and obtained a p-value of 0.07. Now think for a second, is 0.07 less than 0.05? Obviously not, so what do? Do we reject or retain the null hypothesis? We're going to retain the null hypothesis because we found that there was no statistical relationship here. This 0.07 tells us there's no statistical relationship. So that supports our null hypothesis. Now, if you were to take this number and you were to change it to 0.04, so now think of this number as 0.04, no longer 0.07, that would mean that you found a significant relationship. So you would reject your null hypothesis that there was no statistical relationship. So you retain it if the p-value is greater than 0.05. You reject it if that p-value is less than 0.05. 0.05 or less, rather. So if you find a relationship of 0.05, that's significant. That's within the threshold we're looking for. All right. So we're going to practice some p-values here. So if a p-value is 0.002, do we reject or retain the null? And was our hypothesis supported? So you're going to answer the second question with the first one. So in this instance, we're going to reject the null because the 0.002 is less than 0.05, and we're going to retain our original hypothesis that the amount of time watching TV is associated with obesity. So Dr. Y's hypothesis is that disengaged parents are more likely to have anxious kids. So the p-value is 0.1. 0.1 is greater than 0.05, so we're going to retain our null hypothesis that disengaged parents are equally as likely to have anxious kids, and that's not going to support our original hypothesis that disengaged parents are more likely to have anxious kids. So you can see retain and no. So Dr. Z's hypothesis that the number of friends someone has is not related to happiness. Now this is a tricky one. Your p-value was that 0.79 is greater than 0.05, so you found that there's no relationship, not related. So what do? Do you reject or retain? You're going to retain your null hypothesis because there is no significant relationship there, as the null hypothesis states. However, since your research hypothesis was that there is also no relationship, then you are supporting that. So it is retaining its null hypothesis and you're supporting. So you can retain your null hypothesis and you can support your research hypothesis if they both are the same. However, if you are saying that there is a statistical relationship between your variables and you find that, you're going to be rejecting your null hypothesis. So now we're going to talk about correlations. This is going to be the stuff that we're going to be doing later on in these lectures. So for correlations, you're simply looking at if two values correlate. You want to look at two quantitative or continuous variables. Those are the variables like age, where the number is continuing. Now, categorical variables like gender and ethnicity, you won't be able to run a correlation with those. You have to have two quantitative variables. Think of scales, how old someone is, things that are continuous. They can be positive or negative, and we're going to see some graphs later on. Positive correlation between two variables means that as one variable increases, so does the other. So as you get older, your IQ gets greater. That's a positive relationship. So your IQ gets higher as you get older. A negative correlation between two variables means that as one variable increases, the other decreases. So think of that in the same example. As you get older, that's increasing, your IQ drops. That's a negative relationship. So as you get older, your IQ decreases. Now you're going to see a negative correlation between those variables. So it is reported as an R. Your coefficient is R. Notice it's italicized. We'll talk about that later. So possible R values range from -1 to 1. Think of it as a continuum with 0 being in the middle. 0 signifies no relationship, super easy to remember. Negative signifies that there is a -1, especially signifies that there's a perfectly negative relationship between the variables. So a negative correlation up here. and a positive one signifies a perfectly positive relationship. So think of positive correlation up here. So anything in between, you need to look at the p-value to determine if that relationship is significant. But if it's a negative, it is a negative relationship. If there's a positive, it's a positive relationship. Really easy to get your brain around once you see the numbers. So here is a scatter plot. You're going to be building these in SPSS, and you can kind of see a little upward directionality here. So maybe a few out here on the outside, but primarily you're seeing this positive relationship. So if you fit a line to it, so amount of puppies and age, amount of food a puppy eats and the age of the puppy, you're going to see positive relationships. When you fit a line, you're going to see that going up. So whether that relationship is significant or not depends on your p-value. So here's some practice with correlations. So you can look here, and we'll just start with the first one. The number of hours watching TV is correlated with a person's weight. So that's a positive relationship. As the hours of TV increases, you expect a person's weight to increase. And you find that here with your R. You also find a significant p-value. This p-value is less than 0.05, which means it's significant, which means that you've supported your research hypothesis and you can reject your null hypothesis. You found a significant relationship there. Let's go to the last one. Dr. Z's hypothesis that the number of friends someone has is not correlated with happiness. So let's look here. So we found a negative relationship. So as friends increase, we don't see a relationship at all with happiness. So we're not really talking about a correlation here. We're not talking about a significant relationship. We are stating a null hypothesis as our research hypothesis. There is no statistical relationship here, and our research confirms that. So there is a slight negative correlation here, 0.06, negative 0.06. So very, very slight, just to the left of 0, and it's not significant. So we are supporting our hypothesis, and we are also supporting our null hypothesis, since they are the same in this case, that we're saying there is no relationship. So now we're going to dive into our, close this out. We're going to dive into our next one, which is this how-to document, SPSS Pearson's Correlations How-To. We're going to be working with a music.safe data set. So let's go over here. I have my Citrix receiver open up. You open up IBM SPSS Statistics. If you don't remember how to open up Citrix receiver, type in vlab.unf.edu, press enter, and then it's here for you. You might have to log in with your UNF and number and your MyWings passwords. The same username and password you use for MyWings, use for this. So when you open up SPSS, it's going to look like this. You're going to want to find the music save file. Since we've worked on it before, it's in my folder, but if it's not, you can just open up the file here. And it would be somewhere in your downloads file if you downloaded it. If you want to use your computer's files, you can go into the network up here, this PC, documents, things like that. It'll be in there. Downloads, here's it right here for me. So you just have to learn how to find it in this little area up here. If you're having difficulty, just contact IT and they'll tell you where to go. But once you get it open, assuming that you were able to, have all of our variables here. Now we're going to run some correlations on this. We're just going to follow along with this paper right here. So we want to look at a hypothesis. So our hypothesis is that a researcher is interested in the music purchasing habits and hypothesizes that the more people listening to music, the more albums they own. So the more they listen to music, the more albums they own. We're talking about a positive linear relationship here. Positive. As the more hours they listen increases, so does the ownership of albums. Positive. Our null hypothesis, obviously, is that there's no linear relationship between hours spent listening to music and number of albums owned. So again, no statistical relationship is going to be our null hypothesis. So now that we have the data set open, the first thing we want to do is go to Analyze. You're going to go down to Correlate for correlation and Bivariate. Bivariate meaning 2 or more variables. So we're going to click that here. So hours spent listening to music right here time spent listening to music. You can drag this over if you can't see the whole variable. So let's click on that, double click it, you can press this little over arrow to get it there. And then you want to look at total albums, number of albums owned. So right here, total number of albums. We're not done yet, so don't press OK. Correlation coefficients, so you're going to look at a Pearson correlation coefficient. For this class is all we're going to use. Don't worry about Kendall's or Spearman. We're just going to work with Pearson. In experimental classes, you might try with some other ones. They just give you some slightly different answers depending on the data you're looking at. But then you want to look at two-tailed significance. The best way I can describe two-tailed significance would be to draw it out. So let's open up a new Word document. So think of it this way. We'll do a draw feature. Here is your distribution. Looks hideous. So something like this would be your distribution. So this is your standard distribution with your center here. So two-tailed significance looks at the standard deviation out at the 1.25. So out here. So this is what a two-tailed p-value gives you. It gives you significance for everything outside of your normality. Anything out here. So two-tailed. Tail here, tail 1, tail 2. Anything out here is going to be significantly different than what you're seeing right in the middle. So that's the best way I could explain what the two-tailed value actually means. So let's get back to our SPSS. So you want to go to options. You're going to save yourself some time here, and you just click means and standard deviations. You don't have to run it in frequencies anymore. You can do it right here for some basic means and standard deviations. And now that you're ready, press paste. It's going to be the button next to OK right here. And this is going to bring up your syntax. Syntax is really important. It gives you a breakdown of what the computer is being told to do. So if you are sending your data to a professor, they may ask, okay, give me your syntax so I know what you're doing, so I know what variables you put in. As you can see right here, SPSS has been told that variables I'm looking at are hours and total album. I'm looking at two-tailed significance, and I'm also getting my means and standard deviations, descriptives, and my missing is going to be pairwise. So it's going to take care of the missing variables for me that I've put in. So after you've identified that everything looks good there, you're going to click this little play button. It's going to be your run all, and it's going to give you your outputs. So now let's look at these outputs a little bit. You have your N right here. This is your population. So number of people in each one of these groups, or number of people that responded to these questions. And then now you have your p-values right here. Significance, two-tailed, that's going to be your p-value, 0.793. So that is greater than 0.05, so we can't say it's significant. Now let's look at our Pearson correlation. This is our R value, our R coefficient, our correlation. And this is negative 0.085. Not much of a relationship here. It is a negative relationship, and we didn't find significance. So we are going to retain our null hypothesis that there's no statistical relationship between hours spent listening to music and albums owned, and we're going to reject our research hypothesis that there was a relationship. So this table is telling you everything you really need to know to talk about the information. So if you go down, let's talk about a graph. So we're going to make a scatter plot of this data just to identify what kind of relationship we have. We know no one exists, but let's take a scatter plot anyway. So you're going to pick graphs right here. So graphs up here. Click on chart builder. We're going to build a chart. If this pops up, just click OK. Don't ignore the box, no big deal. So now you're going to click scatter plot in this choose from options right down here, scatter/dot. Then you click your first option here. Just double click it. Now it should load and look something like this. Don't worry about this element properties. We're just going to drag. So let's put total number of albums owned right here. And now let's put hours spent listening to music up at the top. So let's find it, time spent listening to music. And now we have all of these. This is how the setup should look like. Now you're just going to press OK to get in your output. They'll build the chart for us. As you can see, no clear relationship here. You can see somewhat negative with the highest variable being here, kind of a slope down, but you see all these outlier variables here. So there's not really a relationship here. If you were to fit a line to this, which you can do, double click the graph. Let's double click the center. Just click twice in the middle, in the open area here. Make sure it's out here. Don't click one of these. Let's just make it white here. Make it nice and clean. Alright, now it's cleaned up for us. And now you're just going to fit a line on here. So you just click this Add Interpolation Line, and this gives you a up and down version of what it looks like, but you want to give more of a slope line. And let's give it a path. That looks pretty ugly too. So the data is not even clean enough for us to actually do a line on. So I wouldn't worry about it too much. We can just leave the data as it is. If you have cleaner data, then it'll be a little bit better. But for all intents and purposes, this is fine for what we're doing here. So that's all for this video. For the next video, we're actually going to go and do some examples. So talk to you guys soon. Have a good rest of your day.